Oh, hey there, Mission Control. Got a few little chores to do tonight. We got to install a new Arduino on this unit because I broke it. Stupid. And we need to do a fit check on our louver stop. So we're gonna jump in here. See a little power disconnect there. This is one that has my custom board on it. There we go. All right. Plug that back in. The one appears to be powered up here. And then we gotta install this bad boy. There we go. And that should be that. We'll have to check that. So that's nice. At least they're somewhat, easily maintainable for repair. And what happened is I was installing this quick access cord here, so I don't have to keep taking these apart. That's something in the future iterations I need to have is a connection port that's installed on this. But right now I just have these hanging out here, so that'll work. We'll check the server, make sure that's running, but should all work fine. Let's go check it out. All right. Open up this. Nobody looking. Don't get to know what my password is. Get to see my shoulder though. Okay, check the logs. System log coming up. What is going on? Okay, it turned back on. Looks like there was an error when it turned on, so we'll have to keep an eye on it. But looks like the replacement's working. We'll get the other task done and we'll come back and see how this one looks. I'm excited because I got these Crocs off of Amazon and man, they're nice. That's not an advertisement. I actually had Crocs when I was in Iraq. I really liked them there. And I got them here. And they're just nice to slip on and off. So I'm not saying they're the best or anything, but they're nice. They didn't pay me for that either. That's free advertising for them. Crying out loud. All right, what am I here to say? I just think it's cool to see the light in here and look at how well the lettuce is doing. We got kale and all these different lettuces and they taste really good. We're having salads out of the building. It's not even the Martian challenge yet and we're having salads out of the building. Way cool. And I did not think about it, but today we actually received another shipment of fish. We got another 100+ fish brought into the system. I was out my normal job. I didn't have anyone here to do the camera, so I'm sorry, but we got more fish in the system now. Everybody appears to be happy, so it's way cool to see. Man, stuff's really happening here. Got the lettuces kind of figured out. Let me show you the hydroponic experiment, how it's going. So here we are at the hydroponic experiment, and man, everything is actually looking really, really good. It wilted a little bit when we first made the transplant, which made sense. But since we put it in, we've got growth. We got lots of water in here. In fact, I think I put too much coco coir in these first few, but the rest of them actually, where I don't even have stuff in it really. Here you can see the roots. Nice healthy root there. Looks really good. And that's just gonna grow out into the water and it's just sitting, these are just sitting in the water. It's amazing. So here's my hypothesis on this thing. I've been thinking about it a lot. This is an experiment. We bought this table because we needed more table for microgreens, but I saw what people were doing and basically I said, it's a waste of space to put lettuce into a media bed. It's just waste. Don't do it. It's a waste. You don't need a media bed for lettuce. They're low stature crop. They don't need a lot of space to grow. In fact, this will probably do the job here for what we need. We weren't using our space effectively. So I was like, okay, how do we get it out of the media bed? So I bought these rafts because that's what other people do in the deep water culture method of aquaponics or hydroponics. And I was like, all right, so here's the theory on DWC, deep water culture, is you have about 12 inches of water and you get your organic, your bacteria, they line the bed that you use. They stick to the side of it. And that bacteria takes the fish water, which if you don't have media beds, you need to filter to get the solids out of it, and you need to run that water in here, and then the bacteria does its job, and you need a certain amount of surface area for that all to work. So you need a bigger bed, a deeper bed for it to work. But my hypothesis is that I already have 12-inch deep media beds, which are filled with rock, which have a ton of active surface area on them, because each rock, you know, has surface area all over it with cracks. So lots of bacteria in the system, converting that water, taking care of the nitrogen cycle, converting the nitrites into nitrates, etc. And I think I'm going to have good enough with this bed, that's the hypothesis, to actually grow the lettuce and sustain it without having to have the deep water culture beds. Said differently, I think because of my media beds, I can get away with shorter beds up top. We'll see. And so far it's looking good. We got to see it to the end though. We can't declare victory until we actually see the end of this experiment. But so far it's looking really good. And I like what's happening here. All right, here we go. We are going to check out and fit check our leuver solution here. All right, problem number 1. Ooh, few problems there already. Boy, that's why we do this. That is why we do this. For show. All right, so here you can see my jimmy rig, right? We got some plumber's tape, and then we have the PEX on there, and we got these two. We got the screw going through there, holding that all on. Yeah, so we're gonna replace it with this, which looks way nicer, but already see some problems with it. First is that while the hole is 1/4 inch, it needs to be flared out at least, boy, another 1/16 of an inch. So we need to holes plus 1/16. Okay. The spacing, does the spacing look right? Boy, that's awfully tough. It looks like it's off a little bit. And I don't really want to take that all the way apart to get to it. What's an easy way to do that? I have my calipers here. Okay, on. Ooh, you know what? If it, yeah, I'm not going to be able to do that because that hole interferes. That's not going to work. So it has to be a single hole solution. This is the beauty of 3D printing is, you know, you can sit there and be like, hey, you know, I'm going to use both holes. I'm going to do this as simple design. You take some measurements. I got pretty close. I mean, I'm just off a little bit here and there, but you come out here and you're like, okay, now I have a real part. I'm looking right at this thing and I realize, you know, that dog, he ain't going to hunt. So we got to deal with that. And really what it says is you need the thick part. You need the bolt to go right through the thick part, but then that thing's going to turn. So then if I printed wings on it, all right, so there's the game plan. We're going to put wings on this thing. The wings are 0.7. So 0.7, we'll just call that 0.8. 0.7765. That looks like 0.8 to me. All right, so I think what we're going to do is we're going to modify this a lot, use less material. We only have one hole to work with, so I'm going to use the edge, 3 edges of this bracket here to hold the solution. So we got a single hole. That means that this whole bottom part goes away, and then this whole part, top part, moves down. Is that acceptable? Yeah, because otherwise it's going to interfere. And you actually really need to flip the whole thing So we're going to put that right in the corner. Basically, we're going to get rid of all of this, right? And we're going to put wings on it, and then we're going to put the hole right in the middle. Boom, right there. And then we're going to have wings going over the edge of this, this, and this. So it sits right on there, but it can't go too far because it'll then interfere. Okay, so I put that there. It's got to be from there, there, and then got a little bit extra, and then we're going to put wings on it. A wing here, a wing there, and a wing there. That will stop, okay. That'll stop torque that way. It'll stop torque that way, but it does need to be pretty thick. All right, so it's pretty amazing what you can do with a set of calipers, a pen, a paper, CAD, and a 3D printer. You're like, dude, really? If you're going to Mars, take a 3D printer and lots of filament because you're gonna need it. Things are awesome. I think they are. If you get one, trust me, you're gonna know what I'm talking about. They're cool just to play around with. Like, hey, I printed a Terminator head the other day. Way cool. But this is what it's all about. Out here, this is called rapid prototyping. I have a problem. I could go to the store, I could jimmy rig something on it, I could go buy a piece of metal, I can bend it, I could do all that. Or I'd come out here, I'd take some measurements, and if I was really serious the first time, like if I really sat down and spent a lot of time on it, I should have got all these measurements the first time. So I probably could have printed this once and been done because it's pretty simple. But I'm printing it twice, hardly any time really for me to do it. Learn a lot. As soon as you have a real part in your hand, you're just like, boom, I got it. I go put it up there, see how it works, see how it doesn't work, take some notes. I got what? 1, 2, 3, 4, 5 things really to do to this, and then it'll all be really dialed in. So pretty happy with that. So we're gonna get inside, we're gonna put it on CAD, see what we can do there, and get it printing. The potatoes are flowering. Yay. All right, so I've got the third prototype. So let's look at these real fast, kind of get closer so you can see them. This is way cool about 3D printing. So here's prototype number 1. And the idea was to keep it as small as possible and create a stop that goes like this. And the problem with it, this interfered with the bracket. My measurement was off, and there's not enough distance to actually use the 2 holes that are there. You can't actually do it, so that was just a misread on my part. In addition, it would rock. There was no stops because it would be connected to a flat bar, so it could still rotate like this, or yeah, like this. Yep. So then this is prototype number 2. You can see it has 1 hole in it. It now has stops on it so that it can't rock as much. I made it longer, or skinnier, I should say. It's not as fat. Didn't need that much material, but the measurements were off by about 0.4 inches. So this is the third prototype that we're going to be testing now, and you can see it still has the single hole solution. It has the stops on it. We cut down the overage, and we actually put in something that I completely missed, which is I had to hook the chain into something so that when it kicks back, it pulls the chain down, because that's what the leuver motor does, is it uses a chain to open the louvers on a spring. So we're gonna fit check this now, and I'm really hopeful that it'll fit, and if it does, we just need to go hit print on this again, and we'll install it on the second one, and this project will be done. So here, let's see if we can get it. Kind of see the evolution of thought as we go here, and I think this is just a way cool part of rapid prototyping. Way cool. So some people will say, well, if you spent more time thinking about it up front, you would be here and not have to go through here. And some of that is correct. But also, I know from experience, and I think many of you out there will know as well, that plans are way cool until you actually go do something, and then you realize you didn't think of everything, and your plan, it goes out the window. So you can spend forever trying to engineer the perfect thing, or you can do good enough and then actually see how it works and iterate on it to get to where you want to be. This method is usually faster than traditional sit down and think for a long time. Now, if your life depended on stuff, I would not say that rapid prototyping is necessarily the way that you want to go. You really do want to think through things. So I think the general lesson here is there's more than one way to skin a cat. And you need to use the right tool for the job. Both those lessons are appropriate here. I would not say rapid prototyping is great for everything, but it's really great for things like this. If I was building a spaceship and someone's life depended on it, I would do a lot more engineering first to make sure I got everything right, at least as close to right as I could. So let's go do a fit check on this and see how it works. All right, headed up the ladder here. Oh yeah, this one's already all wonky. A temporary solution there. So you got this chain here and then it hooks. Ooh, there's a yellow jacket right there. I don't like yellow jackets. Not only is it a louver stop, but it's also an effective yellow jacket destroyer. I don't really want to trim the material off. Here's the reason why, is as it goes back, it's got a lot of force. And it's going to take quite a beating over time, lots of cycles. You know, one cycle here and there, not that big a deal. But lots of cycles. I don't want to remove material because it'll fatigue. Is there a way? So the good news is it really fits on there nicely. Okay, so now we just got to deal with the bolt length and go print another one. So I could shave off a little bit more material to make it really rock and roll. Oh, look at that, it's just a little bit off. So yeah, I could take just a little bit off the back there. Okay, so I think I'm gonna leave this on here and let it go a few cycles today, see how it works. And then I also think I'm gonna trim just the backside off here. I think I'm gonna trim it by, what? Boy, if I took 1/8 of an inch off maybe, this is what, just like almost about 1 millimeter there, right, I think. I think that would really make a difference. But look at that, boy, it lines up nice. It doesn't have any interference, which the other one did. It stops well. I think that's gonna work. So we'll go clean up the back here. We'll hit print. We'll get 2 more of these made for our 4th and final prototype, which will actually be our product. And then we have ourselves a nice louver stop, 3D printed TheRealMartian style. All right, so just got the 4th version off the printer. This is the final version. Has all the issues addressed in it. There we go. So took us a few prints, but we got it. It's all dialed in. Now I have that design, so if they break, I can just go in and print a new one, and life is good. Boy, oh boy, it has worked out phenomenally. It is just perfect. Everything's working correctly. It's able to withstand all the pressure of everything when it's pulled. Had it on there for quite a few days now, and it's just really, really working just awesome. Just really, really, it is so cool to make your own parts. So like, hey, I have this problem, I need a part. I'm gonna go print the part. I'll go design it and then print it. Anyway, I'm not going to Mars without a 3D printer and a lot of filament, or a way I can make, I don't know, carbon filament from CO2. That would be cool. Anyway, so that's it for the build here. We got this thing all done. It came out great, really happy with it. You know what, actually completely separate from the project, it's just a cool story, so I'm gonna tell you. Similar type of situation where a part didn't exist, actually kind of even worse, is when we bought our house 7 years ago, it came with a jacuzzi hot tub, an old jacuzzi hot tub. This is totally a first world problem. And it had a bunch of broken parts on it, and I think 2 winters ago it broke. Didn't drain it, so I needed to fix it, and it just was not on my to-do list. But you know, we've been going so hard lately, and Mrs. Martian kind of secretly really wanted it back. She just didn't make a big deal of it. God bless her. So this last weekend I decided I'm gonna fix it. I'm gonna fix it. So I really got into the thing, you know, and had to do some plumbing to repair a broken pipe, but I also saw all the broken pieces on the hot tub, and I knew I couldn't go buy them because it's so old. But I could print them, and I did. I had like 5 different parts. They're pretty small, but somewhat intricate parts. Just got the calipers out, started drawing everything in CAD. I printed the first version of all the parts, and all of them except for one part came out right the first time. And the second one was just off by like 1 millimeter. So I fixed that, got it all installed, everything works great. 3D printers are awesome. They are a game changer, and I am obviously pretty excited and stoked to even just be blessed enough to have one. But I'm actually using it for stuff. Here in the building, we have this problem that it's been solved, and we have some other prototypes that I want to do, but also just around the house. It's nice to have, especially for things that they don't make anymore. So thanks for following along on this video. I hope you enjoyed it. If you did, be sure to give us a thumbs up and hit subscribe. Don't forget you can follow us on Facebook, Twitter, and on Patreon. In the meantime, this is The Real Martian. Out.